A very good morning to all. As we all know that in today's competitive world, it is very important to be well versed with latest technological developments happening around us. The world is moving at a fast pace. So is the technology. In tune with this thought, the Department of Computer Science KCW keeps on organizing knowledge enhancing seminars and informative sessions on innovative topics. These seminars and sessions help the students and faculty to know the latest innovation in the field of IT. Today's seminar is another step towards making the students of department learn emergent technological innovations. It's a matter of pride for our department that our very own Ms. Rachita Dua, the proud alumni of the department, is here to share her valuable inputs on the topic Git. It has been a boon for all of us, especially for the software developers, as it helps in controlling and handling different projects with high speed and efficiency. It saves time and is one of the effective gateways that has a lot to offer in terms of maintaining coordination among the developers. Ms. Rachita Dua, the guest speaker of the day, will make us cognizant of what this Git is all about. Ms. Rachita did her BCA from KHALSA College for Women and MCA from National Institute of Technology, Karnataka. She has worked at Coffee Table, Ludhiana for 3 years and then moved to Canada. She has also worked as a programmer analyst at Flagship Courier Solutions Point Clear in Montreal. She is currently working as an e-commerce developer at Moose Knuckles, Canada. As an e-commerce developer, she has experience of working with e-commerce platforms including WooCommerce, Magento, and OpenCart. We are indeed honored to have such a versatile personality amongst us, whose presence will prove to be highly inspirational for our dear students. She is an innovative thinker and analyst who approaches the problems logically and has a unique way of presenting the information in a simple and lucid way. Because of her excellent command over the subject of computer science and applications, she has created a name of her own in the arena of information technology. Rachita ma'am, I accord you a warm welcome on behalf of the Department of Computer Science. It will be a great learning experience for our dear students to interact with you. I seize the privileged opportunity to thank our dear Principal Ma'am, Dr. Mukti Gill, whose motivational presence always inspires us to take such initiatives and contribute maximum in shaping the youth of today for a better tomorrow. Students, this is to inform you that kindly fill in the attendance form. The link will be provided in the chat box. So please fill in your attendance before leaving the session. Now, without any delay, let us all gain many things from the experience and expertise of our guest speaker of the day. I would request Ms. Rachita Dua to please come forward and enlighten us on the topic of the day.
Thank you so much, Shikha ma'am. That was rather kind of you. Let's start with it. Please let me know if you can see my screen.
It is visible.
Okay, so basically, today's workshop is going to be an introduction to Git, which is also known as a stupid content tracker. Now, the question arises, why is it called a stupid content tracker among whatever it could possibly have been called? So the author of Git came up with the name Git because, one, he wanted a short word, which was not an existing Unix command. And it can also be taken as a mispronunciation of the word get. Depending on your mood, he said that you can either call it stupid, contemptible, or despicable. Or if you're in a good mood, you can just think of it as a global information tracker. And why is it a global information tracker? You'll know it by the end of this presentation. So in today's presentation, we're going to cover the basics of Git, how you're going to set up a repository, what exactly is the staging area, what are branches, how do you merge branches, and what are the challenges that you face while merging branches, what exactly is a push or a pull, what is a reset, and what does it mean when you have to stash your changes. So to set up a branch or a repository, you basically just use the Git Init command along with the project name. Anything that is in square brackets is an optional parameter. So basically, let's say that you want to create a new repository. I will side by side show you the commands and how they work. Okay, so this is where we were, and I take it that you can all see my terminal right now. So we are in a directory or a folder called KCW. Let's say that I want to start a new project by the name KCW. Whatever files will be there in the project will be placed in this directory. But before I start, I want to initialize it. So my first command is going to be Git Init. Init is the short for initialization. So it says that it has initialized an empty Git repository at this path. If you do -A option displays all the files in the directory, whether they're hidden or shown. It will show you a .git directory. D here stands for directory. This .git directory is going to save all the changes that you're going to make from this moment onwards. Let's say I create a file, index.html. And in this file, I just write one small HTML tag. So very basic HTML. And let's see, now we've got an index.html file in this directory. And what are all the files? There's the index.html file and the .git directory. Coming back to our presentation. So that is how you initialize a directory or a repository. What if you want to work with a repository that was already initialized by someone and it already has a lot of project work done in it and you want to add to that? In that case, you don't initialize it, you clone it. The difference between initializing something and cloning a repository is that when you initialize, you're starting from scratch. So that is basically the first step. You are the one who is initializing and who is starting the project. When you're cloning a repository, that means that there is already data or files existing in that repository, and you are taking it one step ahead. That is the basic difference between init and clone. Moving on. So there's three different areas, let's say, in a Git system. There's untracked files, there's a staging area, and there's a repository. Repository is always the final destination. Untracked files are the ones that you have made changes to. Staging area is when you are sure of those changes and you are ready to commit them. So in general, when you say that you are ready to commit your changes, that means you are absolutely sure that everything is working fine. As a developer, you have made those changes, you have tested your changes, and you are sure that it is contributing to the project and will not break anything. So you are going to commit your changes, and once your changes are committed, they're set to be in the staging area. Once you commit, once your changes are in the staging area, you push them to the repository, and that means that now your changes can be seen by all the other users, seen and cloned by every other user. Now, I would like to mention over here that when you commit your changes, when they're in the staging area, even though you have committed them, they are only still visible to you. The other developers cannot see your changes. It is only when you push your changes to the repository that the other users can see your changes. Coming back to our example, so we have the index.html file. Let's say I create a styles.css file. Again, very basic CSS. Right. Now we've got a styles.css, index.html, and .git. If I say git status, it shows index.html and styles.css. And it also shows that these are your untracked files. Now let's say that I add index.html and I want to get a status of my current repository or my current project. Now it says that this can be committed. It says changes to be committed. This is a new file, but the untracked file is still styles.css. So that means that whatever changes were made to style.css, you are not sure about them. So they are still in your initial area. But you were sure about the changes that you made to index.html and you committed those. You added those and they can be committed. So these are in the staging area and these are in the untracked area. Moving forward. So, like I did git status, it basically displays the status of your current working directory. It tells you which are the new files that have been created. Let's go back. So that's a new file. It says that this is a new file. It tells you which were the new files that were created, which files can be committed, which are the untracked files. And along with that, it also gives you the name of the branch that you're on. We'll cover branches in just a moment. So right now, anytime you initialize a repository, the very first branch that is created is called master or main. So I'm currently on the master branch. The new file that was added is index.html. Because it has no idea about styles.css and because it is still an untracked file, it cannot say whether it's a new file or an existing file. So status basically tells you the current status of your working directory. Add will add files to the staging area. Remove will remove files from the working directory and from the staging area. So if I go back and I say git remove index.html, so let's say it throws an error that this file has changes staged in the index. However, if I try to remove styles.css, there's no issue over there. If we do git status, it's exactly the same. Diff will tell you the differences, and commit will allow you to commit your changes from the staging area to the repository. Again, it is important for you to note that when you want to push your changes to the repository, they need to be committed first. If I try to commit if I try to commit something, right? If you read this message, it says 1 file changed and 5 insertions. And if I do a git status now, it won't show index.html anymore, but it will show styles.css. The reason is that when you committed, all the files that were there in the staging area have been moved to the repository. Your file is still over here. It's just that it does not have any changes from the base file or from the master branch that it would show it to you when you ask for git status. Git will basically tell you the differences that are there from the parent branch or the master branch. We covered this. All right, moving on to branches. So every repository has a master branch that is automatically created when you initialize a repository. When you're working in teams, in larger teams, what happens is, let's say that there are 20 developers on a team, and 5 of them have been asked to fix a bug, while the other 5 have been asked to develop a new feature. The first 5 will be working on this branch, and the other 5 who have been asked to develop a new feature will be working on this one. What happens is your master branch continues through a timeline. There are other developers who are constantly pushing their changes and committing their changes to the master branch. But the 5 developers who were asked to fix a bug, they pulled a branch when the master branch was at this stage or at this commit. Every circle over here represents a commit, and the arrows represent the direction going forward. So the the bug fix branch was pulled from the master branch at this point when it was at this commit, right? The developers made a couple of commits. Let's call this commit A1 and commit A2, and they pushed it back to the master branch. During this time, the master branch also forwarded by 2 commits, which were very different from the commits that were pushed to the bug fix branch. At this commit, there was another branch that was pulled, and it is called the feature branch. Again, there were a few commits made to this branch while developing the feature, and this was pushed back to the master branch. Now, when the bug fix branch was pulled, it was pulled from the master branch. A few commits later, the feature branch was pulled. When the feature branch was pulled, the bug fix branch had already been pulled a while ago, and the bug fix branch will not have these commits. The bug fix branch, when it is merged to master, master will contain all the changes of the bug fix branch and the changes that were made to master while the developers were working on this branch. The same thing happens with the feature branch. When it was pulled, master was at this commit. When it is pushed back to the master branch is the one that will have the commits from the feature branch and whatever commits were made to the master branch. So at this point, the master branch is going to have commits from the bug fix branch, the feature branch, and all the commits that were made during this timeline to the master branch. If we look at this point, the master branch is only going to have commits from the bug fix branch and itself. At this point, even though there were already some commits made to the feature branch, the master branch will not have these commits. Going forward. So again, it's more or less the same example. Your repository, when it is initialized, it creates a branch which is called either master or main. And some developers could be asked to work on a certain thing, and others could be asked to work on another thing. It could be a bug fix, a feature development, an enhancement, anything. So basically, the timeline is dependent on commits. And at the end of the day, it is always going to be the master branch that is going to have everything. The other branches are always going to lack something of the other, or something or the other. The feature branch will not have the changes that are there in the bug fix branch or that are being made in the bug fix branch. And the bug fix branch will not have the changes of the feature branch. The branches are pulled individually, their changes are made on that branch, and at the end, everything comes back to the master branch. So there's something called git log. It basically allows you to see what were the commit messages that were recently made. So if you put a -n and a number next to it, it'll show you that many messages. Let's say that you write git log -n5. It'll show you the last 5 messages, the last 5 commit messages that were made. Excuse me. All right. Now coming to merging branches and conflicts. So whenever we merge branches, I'll go back to this slide. Whenever we merge branches, there's always the possibility of conflicts. But what does a conflict mean? If you think about it in normal day-to-day life, a conflict is basically when two people disagree. Let's say you are saying that master branch has a file called index.html, which should have a certain code. But your friend says that there should also be another code in it. And the two of you start arguing about it. That is what I would call a conflict. And that's exactly what happens when we talk about conflicts in branches and Git. This is how a conflict is represented. So I'll explain you this code. What it means is that the head says that this is required. And the other one says, the other branch says that this is required. This. So what does head and other branch mean over here? Head can be thought of as a pointer, which points to where the branch was when it was pulled. Again, coming back to this. So the head for the bug fix branch would be this commit, whereas the head for the feature branch would be this commit. So when the branch was pulled, where the head was, this was the line. But you've changed it, and somebody else has also changed it. So basically, what we're trying to say is that two developers were working on the same file, developers A and B. A did not know that B was making changes to this file, and B did not know that A was making changes to this file. So when both A and B tried to push their changes, Git got confused. It wasn't sure whose changes to accept. So, of course, both the developers have worked hard and you cannot ignore either one's changes. So it throws a conflict to both of them. It tells B that A has made some changes that you don't have in your file. And Git tells A that B has made some changes that you don't have in your file. So both the developers need to resolve those conflicts. What they need to do is they need to edit their code so that they can have the code from the other developer. That is how you resolve conflicts. Pushing and pulling. If we go back to this slide, we discussed there's something called committing. When you commit your files, they enter the staging area. And when you push your files, the files from the staging area, that is when they get into the repository. That is where you have the word push or the command push. So basically, you use the git push command to push the staged files to the repository. Pull is used to pull the changes from a remote branch. Reset is used to reset your repository. So It can be used with the hard reset option, which would reset your repository to the specified head. And if you use just a git reset, it is simply going to reset your repository to the last change. So head would git reset -- hard is going to take it to the first change, and a git reset is going to take it to the previous change. We'll cover all these commands in a while. Stash, it is going to put your current changes in your working directory into a stash, and you can use them later. It is basically going to ignore your current changes and take you back to the previous working state. So I have created a repository over here. Let's go to this one. So this is the code in that repository. Now, this is the code. Now let's say that someone wants to change this title from Git to Introduction to Git. Again, let's do a Git status. So currently my branch is main, right? And it is up to date with the original main branch. If I do a git pull, it tells me that it's already up to date. Now, the reason is that there's no other developer who has made any changes since my last change, and therefore it is not able to pull anything. Had there been another developer working with the same repository, and they would have made some changes which I had not yet seen or was aware of, a git pull would have added those changes to my branch. Speaking of branches, let's pull a branch and work with that. So to pull a branch, you do git checkout -b and a branch name. Let's call this Introduction to Git. So it gives you a message that it has switched to a new branch called Introduction to Git. If I do a git status, it says on branch this. If you see the difference, earlier it said it's on branch main, and now it is giving me the branch intro to Git, which means that I am on this branch. Now, if I make a change, let's say instead of Git, we write Introduction to Git. It shows over here. Now let's see, if I do a git status, it shows that I have an untracked file, index.html. I'll go with the commands once more so we can follow the examples in the same steps. We covered init, we covered clone. Right, so we did a git status. Now we're going to do a git add, and we're going to add this file, index.html. Again, git status. And now I'm going to commit this change to the repository. A commit should always be accompanied with a message. If I just write git commit, it is going to ask me to enter a message. You enter a message, save it, and now the status says, since it has already been committed, I get the message that there was one file that was changed, there were certain insertions, and there were certain deletions. This has been committed. Now I need to push this to the repository. I'll just take you all to the repository over here. So this is the repository. It says that the last commit was on March 17th. Now, if I push these changes, git push origin, and you always push to the branch name. So intro to Git. It's going to ask me for a username and a password. Now it says that it has been written and I need to create a pull request, and the pull request can be created by visiting this link. So let's do that now. And if you see over here, it says that there was a branch called Intro Git that had recent pushes less than a minute ago. I can compare and pull that request. The same thing is here. If I click on this, it will take me to the exact same thing. Right? So since I am the owner of the repository, I can create the pull request. Anyone can create a pull request, but since I am the owner of the pull request, of the repository, I can merge it. So I'm going to merge this. Okay, this has been merged. If we go back to the code, it now says that the latest commit was now. Moving on. So we have this. Now, if you see over here, it now says that there are two branches. One is called main and the other is intro to Git. If I delete, or better still, let's go to the main branch and make a slight change. Okay, Git for KCW. Now, the change to index.html was made on the main branch by the repository owner. However, when I'm working with this directory, let's switch to the main branch. So when you want to switch from one branch to the other, you simply say git checkout and you write the name of the branch that you want to switch to. It says switched to branch main. Now, the change was made directly to the file index.html on the main branch. However, my current working directory does not know that there was a change made by someone else to a file that I'm working with. So at this point, if I say git pull, it is of course going to ask me for a username and password. Right. So if you see over here, this line, index.html /+/-. It basically tells you which are the files that were changed. So index.html was changed. It tells you how many files were changed. One file was changed. There were 2 insertions and 2 deletions. I hope that this clarifies the concept of git pull and git push. Going back to here, track files, commit, pushes. All right. So we covered branches a bit. Obviously, mergers and conflicts will be more clear to you once you guys start working with branches yourself. And once you see that when the same line on the same file is edited by different developers, that is when you generally run into conflicts. Logs, of course. So if I say get log, so it shows me the last messages. Now, since this is a new repository, it does not have many commit messages. So the first one was initial commit, then there was a readme, a change title, the merge pull request, and update index.html. HTML. If I say get log -n2, let's clear this first. So it only shows me the latest two commit messages. Back. Okay, merges, branches and conflicts, pushing and pulling, reset, of course. So there's index.html and assets files. Okay, let's make a change to index.html. Excuse me. And I would also like to make a change to style.css. Let's see which classes we used to be here. H2. Okay, I'll just randomly create a class. Right. Now, if I do a get status, it shows me whatever changes I've made. When you have a lot of files that you change, you cannot explicitly add one file at a time. Of course, you can do that, it's possible, but it's very tedious to do that. So what you generally do is you do get add dot. Dot means it's the current working directory. So whatever files are listed over here, they will all be added to your staging area. Now, if I do a get status, it shows that all these files have been added to the staging area. Now let's say that I wanted to add all the files except one, but I did a git add. So what I'm going to do is I can do a git reset along with the name of that one file that I want to remove. So let's say I want to remove style.css, so assets, css, style.css, gets reset. Now if I do a get status, it shows that index.html is staged. It's in the staging area and is being tracked, whereas assets, CSS, style.css is not staged. That is what a git reset does. Git stash. So I made some changes to index.html and I made some changes to style.css. Now, if I do git, let's commit this first. So for committing, you do git commit -m. -m stands for message and whatever is the message. So the changes that were staged have been committed. Now let's say that I made a blunder. I want to pull back my changes. So what you do is you do git stash and your changes are back to the previous commit. That was that. That's pretty much all the basic commands in Git. You can all use this repository. You can clone this, make changes, and it's going to be a public repository. You can make changes amongst yourselves. Try pushing to the repository. Don't worry about it. You won't be able to break anything, so try as much as you want to. And yeah, like experiment with it. The more you experiment, the more you learn, and ask your questions, whatever you may have.
Thank you so much, Rajita ma'am, for such a knowledge enriching session. It was indeed a fructifying experience for all of us. Students, if you have any queries, then please feel free to ask. You may type it in the chat box.
I've pasted the link for the repository in the chat box. Feel free to clone it or work with it however you may want.
Rachita ma'am, there is a question. How data redundancy is reduced using Git?
Now, data redundancy is reduced. So basically, if you have redundant data, um, it's not exactly all right. Let me share an example with you. One moment, I'll just share my screen. So whenever you're working with Git, the best practice is before you start working, you should always pull the changes that were made by someone else. Right. So what happens is that when you do a Git pull, you are getting all the changes that were made by any other developer. So that way, your project is updated automatically, and you will not make the same change that some other developer has made. So therefore, you are avoiding redundancy from the very beginning rather than tackling it at the end. I hope that answers your question.
Thank you so much, ma'am. Ma'am, next question is how to check.
Sorry, ma'am, I cannot hear you. You're probably on mute.
Is my voice audible now?
Yes.
How to check if Git is available on your system? There is a question.
Okay, so if you are currently on your system, just type git. And if you are on a Unix environment, it will tell you that you currently do not have Git installed. You can install it using sudo apt install git. If you are on Windows or if you want a visual, so for Windows, you can download git.exe. I believe that should be easily available. For again Unix based systems, you have the command line. For Macintosh systems, again, you have the command line interface to download it. So whether to check, uh, in order to check whether you have it or not, you just need to type the word git and it will tell you whether it is already installed or if you need to install it.
Thank you so much, ma'am. Next question is why GitHub is vital for organizations?
Well, so that the developers are not doing redundant work. It's like so all developers can collaborate on the same repository rather than, let's say that you are working from Ludhiana and another developer is working from Bangalore. So the two of you don't have to send each other your code. Okay, this is what I finished yesterday, and now I'm emailing you all of my code changes so you can start from here. The other person, when he starts his work, he can just do a git pull and he'll be able to see whatever changes you had made.
Thank you so much, ma'am.
And just to add to that, Git is not just about GitHub. GitHub is one website that offers you repositories that can be controlled with Git. There are tons of other websites. One of them is Bitbucket, if you've heard of that. There's one called GitLab. Git is basically a command line tool that helps you maintain repositories. Now, those repositories can be on any platform. It can be GitHub, it can be GitLab, Bitbucket. I'm sure there are others that I don't know of, but that's just a tool. So let's be clear, GitHub is a platform while Git is a tool.
Thank you so much, ma'am. Students, if you have any other question, then please feel free to ask. I think there is no other query left. Thank you so much, Rachita ma'am, for making the learning experience an overwhelming one. I'm sure the knowledge you have shared will open new gateways for our dear students. We'd love to strengthen the bond with you and would love to listen your inputs on new topics and arenas. I would also like to thank our worthy head of the department, who is a woman behind department's ever increasing accomplishments. Thank you so much, ma'am, for giving us opportunities to widen our horizons on new topics every time. Thank you so much, dear students, for being an interactive audience. Thank you, one and all. Thank you so much.
Thank you, everyone. Thank you, ma'am.
Thank you so much.